Good afternoon, children, and I welcome you all to the part 2 of Electrochemistry PYQs. Right, so in the last class, हम लोग discuss कर रहे थे कि the types of question that had come in the previous years, and today we are going to have some more question. ये session थोड़ा छोटा रहेगा क्योंकि maximum questions हम लोग last lecture में discuss कर लिए हैं, and in this section, the few questions that are remaining, we are going to talk about those concepts and topics. Okay, so let us move on to the first question. And what I want you all to do, as always, you pause the video and I'll give you a minute and you have to try to at least find the approach how to solve the questions, right? Okay, so let us begin. So the first question on your screen, everyone pause for a minute and try this. Okay then children, time up. We'll see what's given here. It is given that potassium chlorate is prepared by electrolysis of KCl in basic solution as shown in the following reaction. So basically it is talking about electrolysis, and whenever we talk about electrolysis, we know that electrolysis has two laws, that Faraday's two laws. Yes, okay. And the first law, as we discussed, that W is equal to ZIT can be used. Yes, this is one equation that comes from the Faraday's laws. Okay, so it is given here that potassium chloride is prepared by electrolysis of KCl in basic solution as shown in the following equation. And what is the equation given us, children? It is given as 6OH minus plus Cl minus give rise to ClO3 minus plus 3H2O into 6 electrons. So this is given to us, and luckily we have been given the number of electrons here. Okay, so then a current of X ampere, so some amount of current. So here X ampere means we have to find out the amount of current that has been passed. So we have to find out ampere, right? Current is being asked to us, that is I is being asked to you, has to be passed for 10 hours. The time is given to you as 10 hours to produce 10 grams. So the amount of substance that is being produced, that is also given to us. So we are being given with W, that is 10 grams. Yes. And the value of X is asked to us, molar mass is given to us, Faraday is given to us. Yes. So now are we going to use this formula? Yes, we are going to use this formula, but we have to use a bit modified form of this. And what is that, children? We know that W is equal to ZIT. Yes, ZIT. This Z can also be written as E by F into Z into IT, where E is your equivalent mass. E is your equivalent mass, right? So if we talk of KClO3 here, okay, KClO3, we can see that here how many electrons are involved in the reaction, children? 6 electrons are involved. So what are we going to do here? We'll write the molar mass and we'll divide it by the number of electrons, right? So instead of E, we are going to write 122.6 divided by, what are we going to divide? The number of electrons that has been involved. And F we all know it is 96500. This is going to be the equation. Then it is I is what we have to find out. And T, what is T given, children? T is 10 hours, right? And all these things sum up to give you W, which is your 10.0 gram, right? So we'll erase the rest of the things. Yeah, I want you all to solve this and find out the answer. I'm not going to solve it entirely here. So this is the formula that we are going to use. I hope you all understood that the motive of this question was to write that it is E by F into IT, right? Okay, I hope you all understood how to find out the equivalent mass here. Then If we solve this, okay, this is going to be 10 and 10 getting cancelled out. Yes, then this is 122.6 into I equals 6 into 96500. You can take some approximations as well. Okay, if I take this will be 6 2s are 12 and this will be 0.64s are 24, so this will be something about 965,000, one more 0 by 24. Yeah, this is going to be that much. And are we missing something out here? Yeah, is there anything else that we miss out here? It's equal to ZIT. Yes, everything has been done. Now if we want it in seconds, so what are we going to do, children? We have to multiply here. You have to convert this. This is given in 10 hours. Okay, this is given in grams, so you can convert this into seconds. Okay, then you will get a different answer here. Yes. Okay, so once you convert it into seconds, you're going to get your answer, and the answer will come out as 1.311. This is going to be your answer. Yes, this is going to be your answer. I hope you'll verify. The important thing here was this formula has been used. So whenever talking about electrolysis, we'll use the concept of Faraday's law, right? Okay, let us move on to the next question. Okay, this is an easy one. Just pause it again and try it. Okay. Okay, so time up, children. We'll discuss this. What is given here? Let us see. I'll read out the question for you. Consider the following equation. An equation has been given, and whatever equation is given, we'll write it down. The reduction of, okay, here, the reduction of MnO4 minus is being given to us. Okay, so how do you identify that a substance has undergone oxidation or reduction? I hope you all know that. And how do we know that, children? We know it, we look at the oxidation number. We look at the oxidation number. For example, if we see here, Mn is X. For oxygen, it is plus. For one oxygen, the charge is -2. And for 4, it is this much. And the entire charge is -1. And the entire charge is -1. So X minus 8 is equals to -1, which implies X equals to -1 plus 8. So here the charge is +7. And here, as you can see on Mn, the charge is +2. So what we are going to talk about here is that Mn has been reduced. How do you know that reduction has taken place? Because the oxidation state decreases. So when the oxidation state decreases, it is reduction. And when from the reactant to product, the oxidation state increases, that is your oxidation. That is your oxidation. I hope इतना जो basic बातें हैं ये तुम लोगों को clear होगा. Okay, so this is the reduction. Also, electron is being added here. So addition of electron is also representing reduction, right? Okay. So what else is given here? It's given that the quantity of electricity required in Faraday. So we have to find out the amount of electricity, the charge in terms of Faraday. We have to term in terms of Faraday for the reduction of how many moles, children? The reduction of 5 moles is being asked to us. The reduction of 5 moles is being asked to us. So let us see here. We know that the concept here is that 1 mole equals to or 1 mole of electron is equal to 1 Faraday. Yes, 1 Faraday that we have discussed. Okay. 1 mole of electron is equal to 1 Faraday, that much we know. Not 1 mole of substance, 1 mole of electron is equal to 1 Faraday. This is the concept here. Now we are talking about 5 moles of MnO4 minus, 5 moles of MnO4 minus. Okay. So if we look at the question, here it is 1 mole of MnO4 minus is being reduced. So can we see that for the reduction of 1 mole of MnO4 minus, we require 5 moles of electrons, right? We require 5 moles of electrons. So for reduction of 1 mole of MnO4 minus, 1 mole of MnO4 minus, we require how many electrons? 5 moles of electron. 5 moles of electron. And as we know, 1 mole of electron is 1 Faraday, which implies 5 moles of electron. 5 moles of electron is equivalent to 5 Faraday. Okay. But this is for 1 mole of MnO4 minus requires 5 moles of electron, which equals 5 Faraday. So, but the question is asked to us about 5 moles of MnO4 minus. So, we calculated 5 Faraday for 1 mole. So, if 1 mole of MnO4 minus, 1 mole of MnO4 minus requires 5 Faraday. The question is being asked about 5 moles of MnO4 minus. So that will be equal to 25 Faraday. So the answer is going to be 25 Faraday. Yes. Is this concept clear here? So we are talking about the electrolysis and the electrons in the Faraday. So that concept is, I hope that is clear to all of you. Okay. So the answer will be 25 Faraday here. I hope it is clear to everyone. Moving on to the next question, children. Okay. Next question on your screen. Pause it and find out the answer. Okay, children, I hope that you understood how things are done. Let us start. What is being given here? We'll draw a line. So let us see what's given here. Find the standard potential of M3 plus to M. So standard reduction potential is being asked to us, right? So M3 plus to M means we are asked about the standard reduction potential. Yes. And the cell is given to us. Okay, the cell is given to us and their concentrations are also given to us. And what else is given to us? So the cell is given to us, so we know that whatever is present on the left hand side of the cell, that is your anode, right? And this is your salt bridge. We know that double, so this is whatever present on the left hand side. Yeah, that is your anode. This double bar is a separation, which is a salt bridge. Yes, and whatever is present on the right hand side, that is your cathode. That is your cathode. And one more process that we need to remember, that at anode, what reaction is taking place, children? Oxidation is taking place. And what is the reaction that takes place at cathode? Reduction takes place. Yes. So these are the basic things you need to know before starting this. And here M3 plus to M, so the standard reduction potential is being asked to us. And here oxidation, reduction. So this is given here. So we'll convert it into the equation. The cell representation is given and we have to convert it into the cell equation. Yes. So let us convert it into the cell equation, children. Okay. I have erased everything. So So M is there, and this side Ag plus is there. So we got our reactants. Yes. Now what's happening? M is getting converted into M3 plus, and Ag plus is getting reduced. But we have to balance this. So because in the initial step, if I write it separately, and I show you, this will be M minus 3 electron give rise to M3 plus. This will be Ag plus 1 electron give rise to Ag. Yes, but if we want to combine it, so we have to multiply 3 here, because we have to make the number of electrons equal, right? So if I multiply 3 here, what am I going to get? 3 Ag plus 3 electrons give rise to 3 Ag. Yes, so now plus 3 minus 3 get cancelled, and if we write the combined equation, children, it will be M plus 3 Ag plus give rise to M3 plus 3 Ag. Yes, so we'll write it here. So this will be 3 Ag plus M3 plus and 3 Ag. Okay, so you understood that how we have written this is the anode reaction, this is a cathode reaction, and we have combined it to get the cell equation. Yes, okay, I hope this part is clear, how to form equations. Moving on to the next part of the question, it is told to us that the EMF of this cell, so E cell is given to us. E cell is given to us as 0.42 volt. Yes, 0.42 volt, and E naught. Okay, so what is being asked us? The standard potential of the half reaction. Okay, so one more is given to us. We have to find out this standard reduction potential, and E naught of Ag plus to Ag is given to us as 0.80 volt, and the concentrations are also given to us. Okay, so E cell, what here, which equation are we going to use, children? Because we are relating this with E cell, so this is going to be a Nernst equation. Yes, this is going to be Nernst equation, where E cell, E is equal to 0.059 by N log concentration of M3 plus divided by concentration of Ag plus to the power 3 here, because the coefficient is 3. Yes, what is E cell here, children? Your E cell here is 0.42 equals 0.059 by N. N is the number of electrons involved, and as we can see in each reaction we made the number of electrons equal, that is 3 electrons. So here it is going to be 3 electrons log M3 plus. M3 plus concentration कितना दिया गया है? 0.001 divided by Ag plus is how much, children? Ag plus is your 0.01. Yes, 0.01 into to the power, here it will be 3. Yes, this will be to the power 3. Yes, okay. Now if we try to solve this, if you solve this, this will become 10 to the power minus 3, and this is 10 to the power minus 2 to the power this is 10 to the power minus 2 to the power 3. Yes, so this is going to be how much, children? 10 to the power minus 6, and if you take here, this is going to be 10 to the power plus 6. Yes, children, okay. So if we take this, just to change here, children, this will be E naught minus, I have left E naught here. Okay, so this will be E naught minus this much. Okay, so this will come out to be this much here. So if I cancel this, this is going to be what, children? Log 10 to the power 3. Yes, and this part will be 0.059 by 3. Okay, I hope this much part is clear. Then I'll erase the above part. Okay, so after getting this much, so we got E naught equals to, sorry, E cell equals to E naught minus 0.059 by n log 10 to the power 3. Yes. Okay. Now we know that this is 3. This is 3. Yes or no, children? Yes. If this is 3, what are we going to get, children? We are going to get E cell is given to us as 0.42. Yes, it is given to us as 0.42. Now, what are we going to get here? We'll solve this. This will come this side to 3 log 10. This is going to be 3 log 10. Yes. So this will be into 3 here. Into log 10. Log 10 is 1. So this will be 1 here. This will get cancelled. Okay. So E cell minus this one. So you are going to get that E naught will be equal to 0.48 volt. So if you solve this, you are going to get the value of E naught as 0.48 volt. Yes. This is what you are going to get. You are going to get the E naught as 0.48 volt. Okay, so we found out this by using Nernst equation. But is this thing asked to us in the question? This is not asked to us in the question. Then what is being asked to us in the question? Now, we know that the equation that we wrote was M plus 3 Ag plus give rise to M3 plus 3 Ag, right? We know that E naught of cell is equal to E of oxidation plus E of reduction. And who is undergoing oxidation? M to M3 plus, and who is going reduction? This one is going reduction. So can I write here, instead of oxidation, I will write E of ox, and instead of reduction, I can write this value because to me the reduction value is given, so which is 0.80, and E naught we found out to be 0.48. Yeah. So E of oxidation is given to us as 0.48 minus 0.80. This is minus 0.32 volt. Yes, this is going to come out as minus 0.32 volt. But are we asked about E oxidation? We got the value of E of M to M3 plus, yeah, as minus 0.32 volt. But you are asked about E of M3 plus to M, right? So you are just going to reverse the sign, which is going to be 0.32 volt. So your answer, children, is going to be 0.32 volt. Yes, 0.32 volt is going to be your answer. Yes. I hope you all understood this question and how to solve it. Okay, let us move on to the next question, children. Okay. Next question on your screen. Everyone needs to pause it and try this question. Okay. Okay, children, let us begin. What is being given here? At 298 Kelvin, the standard reduction potential are 1.51 volt for MnO4 minus the standard reduction potential. That is the E naught value is being given to you. Yes. And what is given to you? This is 1.36 volt for Cl2, and what is given to you here, and this is Cl2, Cl is 1.07, and for bromine, so all these values are being given to you at pH equals to 3, at pH equals to 3. So what is the role of this pH? Let us discuss this. Okay, so it is asking at pH equals to 3 the permanganate is expected to oxidize. So it asking that when the pH is equal to 3, yes, this MnO4 minus can oxidize whom? Okay, so you are being given with Cl2 Cl minus, you are being given with Br2 Br, and you're giving I to I minus. So all these things are given to you. So whom it is going to oxidize, that we will see. The concept here is you have to find out the E cell. What? You have to find out the E cell. So whatever is going to be your E cell value, okay, suppose you get X, it can oxidize them. It can oxidize only those which have lesser E naught values. Okay, which have lesser E naught values, it can only reduce them. It can only reduce them, right? Okay, so let us have a quick understanding of how this is being done. Okay, so we know that we are going to use Nernst equation here, right? But what are you going to use in the equation? क्या equation यहाँ पे use करना है वो हम लोग देखते हैं. तो यहाँ पे हमको MnO4 माइनस है, इसको हमें क्या बनाना है, Mn2 प्लस बनाना है. क्या बनाना है? Mn2 प्लस बनाना है. तो आई होप तुम लोगों को पता है कि इसको बैलेंस कैसे किया जाता है. ये रिडॉक्स रिएक्शन का पार्ट है. MnO4 माइनस से Mn2 प्लस बन रहा है. तो यहाँ पे 4 ऑक्सीजन है. कितने ऑक्सीजन है? 4 ऑक्सीजन. जहाँ पे ऑक्सीजन नहीं है वहाँ पे उतना वाटर ऐड करो. यहाँ पे 4 ऑक्सीजन है, यहाँ पे ऑक्सीजन नहीं है. पर कितने ऑक्सीजन नहीं है? 4 ऑक्सीजन नहीं है, तो 4 ऑक्सीजन ऐड करो. 4 ऑक्सीजन ऐड करने के बाद यहाँ पे 8 H हाइड्रोजन आयंस हैं. पर यहाँ पे हाइड्रोजन आयंस नहीं है, तो जितने हाइड्रोजन आयंस नहीं है उतने H प्लस ऐड करो. उतने H प्लस ऐड करो. देन यू कैलकुलेट द नंबर ऑफ इलेक्ट्रॉन्स हियर. So Mn, this is -1, this is +8, this is +2, and this is 0, right? Because H2O has no charge. So this is +7, and this will come this side, so -2. So total of 5 electrons is being involved. How many electrons, children? 5 electrons. I hope you understood the equation, that how the equation is being taken. Okay, I hope तुम लोगों को समझ में आया कि equation कैसे बनाया गया. इसको लेकर हम लोग चीजें find out करने वाले हैं. Yes. So according to Nernst equation, E equals to E naught minus 0.059 by the value that we are going to put N, and this will be log concentration of Mn2 plus ऊपर रहेगा और नीचे you are going to have MnO4 minus, and this is going to be H plus to the power 8. Yes, H plus to the power 8. I hope इतना पार्ट क्लियर है सबको. यहाँ पे जो Mn2 प्लस और MnO4 माइनस हम लोग ले रहे हैं उसको हम लोग स्टैंडर्ड स्टेट में लेंगे. कौन से स्टेट में ले रहे हैं? स्टैंडर्ड स्टेट में. जब हम लोग स्टैंडर्ड स्टेट में इसको लेते हैं, इसका जो कॉन्सेंट्रेशन होगा वो 1 मोलर हो जाएगा. कितना हो जाएगा? 1 मोलर. तो ये भी 1 और ये भी 1, तो ये बातें यहाँ से कैंसिल हो जाएगा, राइट? तो E बराबर E नॉट का वैल्यू दे रखा है 1.51 माइनस, ओके, 1.51 minus 0.059 by N. Instead of N you are going to put 5 here. Yes, you are going to put 5 here, and this will be log 1 by H plus to the power 8. देखो यहाँ पे सारा चीजें हैं बताने का. क्या चीज़ है यहाँ पे? ये pH का वैल्यू क्यों दे रखा है इसको हम लोग समझेंगे. हम लोग ये पार्ट को थोड़ा सॉल्व करने का कोशिश करेंगे. ये मैं बताऊंगी एंड रेस्ट यू आर गोइंग टू सॉल्व. ओके, तो यहाँ पे जो चीजें हैं ये, इसको अगर हम लोग सॉल्व करेंगे क्या आ जाएगा? log 1 माइनस log H प्लस टू द पावर 8, इतना आ जाएगा. यस, इसको log 1 तो हमारा 0 हो जाता है, राइट? सो 0 यहाँ पे क्या आ जाएगा? माइनस ऑफ 8 log H प्लस, राइट? तो ये 0 तो चला गया. ये क्या होगा? हम लोग इसको ऐसे लिखते हैं 8 इंटू माइनस लॉग H प्लस, और ये 8 जो है यहाँ पे मल्टीप्लाई हो जाएगा. दिस इज गोइंग टू बी मल्टीप्लाइड हियर. यस, क्योंकि इसको हमने बाहर रख दिया मल्टीप्लीकेशन के लिए. ये जो -8 log H प्लस है, ये माइनस log H प्लस क्या होता है? यही तो होता है pH. यही तो होता है pH, ठीक है? तो माइनस log H प्लस की जगह हम लोग क्या डालेंगे? वी आर गोइंग टू पुट इट एज 8 इंटू 3. यस, तो इसके जगह हम लोग क्या डालने वाले हैं? वी आर गोइंग टू पुट हियर 1.51 माइनस 0.059 बाई 5 इंटू 8 इंटू, यहाँ पे इसकी जगह पे हम लोग क्या डालने वाले हैं? दिस इज गोइंग टू बी 5, सॉरी 3. यहाँ pH 3 दे रखा है तो 3 विल पुट हियर. Understood what is the use of pH here and how we are going to introduce pH here? Yes. So this is 8 into 3 is 24. I'll take an approx value, that is 8 into 3 24 is 25. So this will be 5 here. This is going to be 5 here, right? So 0.059 into 5. 5 nines are 45, 4, 5 nines are 45, 49. So this is 4. Yes, 0.495. Yes, so this is going to be 1.510, 0.495. Yeah, so this is going to be how much? No, and a mistake here. 5 nines are 45, 45, 4 carry, 25, 29, 2 carry. So this is going to be 0.295. Yeah, just change it, 0.295. So this is going to be 5 and this is going to be 1 and this is going to be 4 minus 2 is 2. Yeah, okay, so this is going to be 1.22, nearly approx the value that you are going to get the value of E cell is going to be 1.22 volt, right? This is going to be a value of E cell. But are we asked the value of E cell? We are not being asked the value of E cell. Then what are we asked, children? किसको ऑक्सीडाइज करेगा? और यहाँ पे कॉन्सेप्ट क्या था? उसको ऑक्सीडाइज कर सकता है जिसका जो पोटेंशियल दे रखा है, जो ई नॉट का वैल्यू दे रखा है, ई नॉट का वैल्यू जिसका लेसर होगा, जिसका लेसर होगा इसके कंपैरिजन में. किसके कंपैरिजन में? ई नॉट वैल्यू शुड बी लेस देन ई सेल. किसके? इसके ई सेल से कम होना चाहिए. तो इसका वैल्यू आ गया. फॉर Mn वी गॉट 1.22. यस. देन वी आर हैविंग फॉर क्लोरीन. क्लोरीन के लिए हमको 1.36 दे रखा है. फॉर ब्रोमीन वी आर हैविंग 0.54, राइट? एंड नो, फॉर ब्रोमीन वी हैव 1.07, 1.07 एंड फॉर आयोडीन वी आर हैविंग 0.54. तो हमको यहाँ पे दिख रहा है कि 3 ऐसे हैं जिसका वैल्यू 1.2, 2 ऐसे हैं जिसका 1.22 से कम है. वो कौन सा है? एक तो ब्रोमीन है और दूसरा एक आयोडीन है. क्लोरीन का नहीं हो सकता क्योंकि क्लोरीन का 1.36 है जो कि 1.22 से ज्यादा है, जो कि 1.22 से ज्यादा है, राइट चिल्ड्रन? सो क्योंकि ये 1.22 से ज्यादा है, सो वी कैन नॉट डू दिस. तो आंसर इज गोइंग टू बी ओनली ब्रोमीन एंड आयोडीन. So what is going to be your answer, children? Your answer is going to be Br minus and I minus. Okay, I hope you understood how this is done. And जो pH का concept है उसको हमने यहाँ पे कैसे use किया using the log thing. Okay, I hope you understood. Okay, this was a good question. Moving on to the next question. ठीक है, ये वाला easy वाला है, इसको try करो सब लोग. Everyone needs to try this. Okay, children, let us try to solve this. What is being asked here? Standard Gibbs free energy is being asked here. Yeah. And what is the formula for standard Gibbs free energy? It is minus NF E naught. Yes, the E naught, we know that F is going to be 96500. E naught is going to be 0.5332. Yes, only the N value is being remaining. So how do we find out the N value? We'll write the equation and then we are going to find the N value, right? Okay. So if I write it like this, it is H2 to H plus. Okay. So I'll write it H2 plus Ag plus give rise to Ag. So this is H plus and Ag. Can I write it half H2 here? Yes, then it will be all right. So 1 electrons, can I say N is 1 here? So instead of N, we are going to write 1 here. Yes, so if we multiply this, so this is going to be 2 zeros cancelling out here. So this is going to be 53.32, right? So this is minus 965 into 53.32. Yes, so you are going to solve this. Yes, and once you solve this, you'll get the answer. For your reference, I have the answer. and you have to convert, you are going to get the answer in joule because energy is in joule. So you have to convert it into kilojoule. So you are going to get minus 51.35 is going to be your answer. Yes. So I hope you'll find this on your own. Okay, I told you the formulas and everything. Moving on to the next question. Okay, so here is a question in front of you. Now try this, everyone. Okay, children. So let us read what is being given in the question to us here. It is given that when copper combines with Sn2 plus, this equation is being given to us. Okay, a redox reaction is given to us. The Gibbs free energy change for the above reaction at 298 Kelvin is this much. So the Gibbs free energy, that is a delta G, is equal to minus NFE. Okay, this is what we have to find out, right? So here we are not going to find out the standard, we have to find out the E cell. Yes, we have to find out the E cell. Yes, so because we have to find out the E cell, so we can identify from here copper to copper 2 plus is 2 electrons. Similarly, Sn2 plus to Sn is 2 electrons. So N will be 2 here, N will be 2 here. The value of F is given to us as 96500. The only thing that you are going to find out is E cell. E cell can be found out by which reaction, children? By the Nernst equation. Yeah, Nernst equation. So for the value of Nernst equation, we require E naught. And how do you find E naught, children? We know that E naught is equal to E oxidation plus E reduction. Right? So who is getting oxidized? Copper is getting oxidized. So it is given here. Reduction is given to here us here. So you have to take it as minus 0.34 plus. Okay, who is getting reduced? Sn is getting reduced. So that is given to us as minus 0.14. Yeah. So you get minus 0.48 volt. Yeah. This is going to be your E naught. So we got the value of E naught. We'll write the value of E naught here as minus 0.48 volt and we'll remove the rest of the thing because we have to find out the E cell, right? So for finding out the E cell, we have E equals to E naught minus 0.059 by N log concentration of Cu2 plus by Sn2 plus. Yes. So what is the value of E, children, here? E naught will be equals to minus 0.48 minus 0.059 by N. N will be 2 here, right? N is going to be 2. This will be log how much? Copper 2 plus is given to you as 0.01 divided by Sn2 plus is 0.001. So this is 10 to the power minus 2. This is 10 to the power minus 3. Yes. So if you do this, you are going to get minus 0.48 minus, if I cancel this is going to be 0.0295. And this is, when this goes up, children, this is 10 to the power minus 2 and 10 to the power plus 3. So you are going to get log 10, right? This much you are going to get, and log 10 is nothing but 1. Log 10 is 1. So you are going to get only this much. So your value of E is going to be minus 0.48 minus 0.0295 and this is 0, 0. This is 5, this is 9, this is 0, and this is 5. So this is going to be minus 0.509. Okay, so we got the value of E also. Yeah, so we got the value of E equals to minus 0.5095 volt. Yes, so we got everything that we required. Okay. Now, what is the last step remaining? What is being asked to us? The Gibbs free energy change is being asked to us, and what is the value of, what is the formula of Gibbs free energy change, children? This is minus NFE, right? Delta G is equal to minus NFE, right? Okay, so the value of delta G is going to be minus NFE. So N, instead of this, we'll write 2, and F is going to be 96500, and your E is going to be minus 0.5095. So if you multiply this, you're going to get the answer. And what is the answer, children? But that won't be the answer. This is something into 10 to the power minus 1. Okay, this is the value that you're going to get, 983.35 into 10 to the power minus 1. So what are the answer? What is the answer that you're going to write? You're going to write only this as the answer. So your answer is going to be, children, 983.35. Yeah. So this is going to be your answer. Okay. So that is how you were supposed to solve that answer, solve that question. Okay. Moving on to the next question. Okay. Again, you can pause this and find out the answer. So until then, let me check if you have any doubt. Okay, so you solve this, let me check. Okay, children. So let us move ahead and see. This is again a question from Nernst equation. What is being asked here? The cell potential for the following cell. That is what E cell is given to us, right? What is given to us? E cell. So we'll write it down, whatever is given to us. We are being asked about the pH. What are we asked? pH. pH, you should know, it is nothing but minus log of H plus. So that is being asked to us. So we'll find out what is the answer here. But before that, we have to write an equation, right? Because from there only we'll have some reference. So left side is always anode. So H2 minus 2 electron is going to give you 2H plus, right? Then here copper 2 plus 2 electron is going to give you copper. If you combine this two equation, you are going to get H2 plus Cu2 plus give rise to 2H plus Cu, right? So this is your final equation. So we'll not require the other thing. So this is going to be your final equation, and we'll note it down here. Yeah. This is going to be your equation, children. And from this, we can find out the E cell. How? E naught minus 0.059 by N log. Yeah. So we'll take here concentration of H plus to the power 2 divided by concentration of Cu2 plus. Yes. Okay. Now children, E naught, E cell is given to you as 0.576. So there are certain cells for which you should memorize the E naught. Okay, even if it's not given, you can memorize the E naught, and that for your copper is 0.34. Okay, this you should know, because for hydrogen it is 0. So only for copper it is 0.34 minus 0.059 by 2. What is that children? 2. Log, we don't know what this is. If this goes this side, yeah, okay, so now what will happen, this 2 will go this side, okay, and you are going to, this 2 is going to get cancelled, and this you can solve it, and once you solve it, you will have a value of minus log h plus, and what is going to be the answer children? The answer is nearly going to be, nearest integer is being told to you, so the answer is going to be 5. Okay, so the pH, the nearest, the value of pH that you are going to get children is 5. Okay, okay, then let us move on to the next question. So here the motive of this question was that you need to memorize only some of the pH, okay, and then your work will be done. Okay. Another question on your screen. Try it, children. Okay, children, let us see what has been given here. So assume a cell reaction with the following cell equation has been given to here. And the value of E naught is also given to you as 2.97 volt, right? Okay. E cell is being asked to us, very easy. Okay, so E cell will be E naught minus 0.059. Obviously the value of n here is going to be 2, right? Okay, this is going to be 2 into log, this is going to be Cu2 plus divided by Ag plus ka whole square, right? Now why I picked up this question is Ag plus will be easier for you because this is 10 to the power minus 3, right? This part is 10 to the power minus 3 whole square. Yes, but Cu2 plus is 0.250. This is 0.250. But you are being given the value of log 2.5. Log 2.5. So how do you convert it into 2.5, children? You have to multiply 10 here, right? If you are multiplying 10 here, you have to divide by 10 as well, right? So this is going to be 2.5 into 10 to the power minus 1. So this is going to be what, children? 2.5. So instead of 0.25, you are going to write 2.5 into 10 to the power minus 1. Yes. Now once you write this, this becomes easier for you. This is 10 to the power minus 6. So this is going to be 10 to the power 6. Once this is 10 to the power 6. So 2.5 into 10 to the power 5. Right? 10 to the power 5. So we'll get the value here as something, yeah, this is given to you as 2.97 equals E cell equals E naught is 2.97 minus 0.059 by 2. Now this is 10 to the, so this is into log 2.5 plus 5 log 10. Yes. So this is going to be how much, children? 5 log 10, this is 1 here, and the value of log 2.5 is 0.40, right? 0.40. So this will be 1.40. Yes. So this is, I have taken this approximately as 0.40. So this is going to be 1. No, this is going to be 5 into 1 is 5. So this is going to be 5.40, right? So you can erase all of this and you can write this is 5.40. Yeah, so this is 2 to the 4, this is going to be 2.7. Yes, this is going to be 2.7, and if you multiply this, so 59 into 27, 7 nines are 63, 6, 35, and 6 is 41, 18 and 1, this is 11, so 3, 9, 5, 1593 and point before 4, so 0.15 is being cancelled. Yeah. So this is going to be, which implies 2.97 minus 0.15. Yes. So this is going to be, children, 2.82. 2.82. So the nearest voltage, nearest integer is going to be 3. Yes. The nearest integer is going to be 3. So your answer that you are going to get, children, your answer is also going to be 3. Okay, children. So what is going to be your answer? Your answer is going to be 3. Yes. Clear? Okay. So I hope this part is clear to everyone, how to find out this. Yeah, you can take some approximations, whichever you find is like useful for you. Yeah, approx values you can take and find out the answer, won't cause a much of damage. Now this is an important question. Focus. Try this, everyone. Take a minute and try this. Okay, children, let us see what is being given here. It is talking about the oxidizing power of MnO4 minus to Mn2 plus couple is being asked to us, right? Okay. Basically, we're talking about E values here. Yes. Okay. So we know that for the MnO4 minus to Mn2 plus couple, we have MnO4 minus and Mn2 plus. I told you how to write the reaction. So here it will be 4 water and 8 hydrogen. So as in all, you are involving 5 electrons here. Yes, this is the equation. Yes, children. Okay, this is going to be your equation. Once you got this equation, we can write the value of E cell for this. Yeah. So your E cell, I write it E1 here. Why am I writing E1 here? Because I saw that the question is asking that the H plus concentration is changing, right? Initially, the H plus concentration was 1 molar, and there is a second case where the concentration of hydrogen ion is 10 to the power minus 4. Yeah. Now, one more assumption is being given to you here. The concentration of MnO4 2 plus and this is Mn2 plus to be same on change of this, that concentration is same, their concentration doesn't change, only the concentration of H plus is changing. You have to find out the value of X rounded off to the nearest integer, right? So E1 value will be E naught minus 0.059 by N log concentration of Mn2 plus divided by MnO4 minus, yes, into H plus to the power 8. H plus to the power 8. So in the first case, the concentration of H plus is 1. Yes. So instead of this entire thing, I can write 1 to the power 8. 1 to the power 8 is nothing but 1 itself. So this part got cancelled. This part got cancelled, and this is going to be your 5 electrons. This is going to be 5 electrons. Yes. This much part is clear, children. So this is going to be your first equation. Coming to the next part. Now E2. So E naught minus 0.059 by 5 log Mn2 plus MnO4 minus, this is H plus to the power 8. And what is being given here, children? 10 to the power minus 4. 10 to the power minus 4. So instead of H plus, I'll write here 10 to the power minus 4. Yes. So if I write 10 to the power minus 4 here, so if I take it above, if I'm taking it above, this is going to be how much? 10 to the power. So if I take this above, 10 to the power minus 32 will become into 10 to the power 32. Yes. Can I say that we are going to get this? We are going to get this. Yes. Okay. Now this is going to be your second equation. Yes. So this is basically log 10 here, log 10 here. So if I want to find out that how much change has taken place. Okay. So if I tell you the magnitude E1 minus E2, so this both are going to get cancelled. And what is going to remain then, children? 0.059 by 5 into 32 you are going to get. You're going to get into 32, right? So if you solve, the magnitude of change is this much. So that is being given to you as something into x to the power x into 10 to the power minus 4. This is being given to you. So if you solve this, you are going to get something into 10 to the power minus 4. So what is that something, children? That you have to find out. Once you solve this, you are going to get this answer. Yes, so you can take an approximation here. This will be how much? 5, 6, and this is 6.4, and you can multiply and you can get this, right? So the main thing here was consideration of E1 minus E2. You can take mode of this, yeah, to avoid any negative values or anything. Yes, you can do this for your reference. Okay, this is going to be your value, which is 3776. Okay, moving on to the next question, children. Yeah, try this. Okay, this is an easy question, but there is one concept that is being involved here. So what is being given here, children? Let me read out the question for you. It is given that for an electrochemical cell, this equation is given Sn to Sn2 plus. So we have Sn plus Pb2 plus, and that gets converted into Sn2 plus Pb, right? So this is going to be your equation. Once this is going to be your equation, we know that we have to find out what the ratio of Sn2 plus by Pb2 plus. Yeah, this is what we are supposed to find out. Yeah. Now, an important thing which is given to us here, this we have to, instead of taking 0.059 by n, we can take 0.06. We can take 0.06 here. Yes. So if we see here, our E cell is equal to E naught minus 0.059 by n log of Sn2 plus by Pb2 plus. Now, children, can we find out the E naught? Yes, because Sn has undergone oxidation. So have we given oxidation? No, we have given the reduction. So Sn to Sn2 plus will be 0.14. Pb2 plus is given as 0.13. So this will be minus 0.13. So this is going to be 0.01. Yeah. So here, instead of this E cell, now what are we going to put instead of E cell? This is the thing here. Instead of E cell, we are going to put as 0. What are we going to put? We are going to put as 0. Why? Because it is in equilibrium. And at equilibrium, thus this point is important. At equilibrium, the E cell, the EMF of the cell is 0. The EMF of the cell is 0, right? What, children? At equilibrium, the EMF of the cell is 0. Yes, the EMF of the cell is 0. Okay. Okay, so I do not want any kind of disturbances in this class. If you cannot keep quiet and sit properly, right? Yeah, you shouldn't come here to waste your time. Anyways, so this is E cell is 0. So instead of E cell I can write 0. Instead of E naught I can write 0.01 minus 0. Instead of this thing I have to write 0.06, right? This will be 0.06 by N is 2 here. Log SN2 plus divided by PB2 plus. So if I write this, this is going to be minus, I'll take this side, minus 0.01. This will be 0.03 is equal to minus 0.03 log SN2 plus by PB2 plus. Yeah. Now, can I bring this one to this side? So this is going to be minus and minus is going to cancel. So 0.01, 0.03 is equal to log of SN2 plus divided by PB2 plus. Yes, children, this is going to be the answer here. Now, so what are we going to get? This is going to be 1 by 3. This will get converted into 1 by 3. The points will get cancelled. 1 by 3 is equal to log SN2 plus divided by PB2 plus, right? Okay. Now, we want only this value. Only this value. So, you have to take antilog. So, this will be 10 to the power 1 by 3 will be equal to SN2 plus divided by PB2 plus. Divided by PB2 plus, right? So 10 to the power 1 by 3 is nothing but the cube root of 10, right? So cube root of 10 is nothing. So we know that 2 into 2 into 2 is 8. So just little bit more than 2 is your cube root of 10. So this is going to be around 2.1 or 2.2. So I'll take it as 2.1. Yeah, 2.123 or something like this. This is going to be 2.15 is going to be your answer, right? 2.15 is going to be your answer. Okay, I hope everyone understood this. Moving on to the next question. Okay, the next question on your screen here is, this is probably the last question. For the reduction of NO3 minus ion, the E naught is given to you. Yeah, the E naught of the cell is plus 0.96 values. Now it is asking that the pair of metals which can be oxidized by NO3. We know that those can be oxidized which have lesser value than this. Yeah, so this is having lesser value, this is having lesser value, this is not having lesser value, this is having lesser value. So there are three options which are having lesser values in this, and which is your vanadium, iron and Hg, right? Yeah, vanadium, iron and Hg. And where do we have these options? We have vanadium and Hg, we have Fe and Hg. Yeah, there's a mistake in this question. I think we should be having three of this. So V, Fe and Hg is your answer. Okay, V, Fe and Hg is going to be your answer. Okay, children. Okay, so that's it for today, and with this we completed our electrochemistry, right? So we'll pick up one more chapter in the next class and we'll try to complete it, right? Okay, so until then, children, take care, bye bye, and I'll see you in the next class.